So the problem statement is you are given an integer array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can either climb one or two steps, right? You can either start the you can either start from the step with index 0 or the step with index 1. Okay, see, these are the steps. Okay, either we can start from index 0 or we can start from index 1. Okay, out of this one we have to choose one. Okay, we have to choose one. The test case given is this: 10, 15, 20. The staircase will be like this. Okay, imagine you are here and you have to choose whether to start from 10 or from 15. That is, whether to start from 0th index or to start from 1th index. Okay, so how will you choose? If you choose like this, that out of 10 and 15 minimum is 10, so just pay 10 rupees and start from here. Okay, then either start from 10 or 15, but 10 is minimum, so let's start from 10. So we have to pay only 10 rupees, and we are on 10. Okay, we paid 10 rupees. Then we have two options: either go on here or go on 30. So where you will go? Out of 15 and 30, 15 is minimum, so let's go on 15. So the cost is now plus 15, 10 plus 15. Now from 15 you can directly go outside. Okay, the staircases are finished now. Hence, what you will do? The cost will be 10 plus 15, that is 25. You will return 25, but it will show wrong answer. Why wrong answer? That does not work like that. See, if we chose 15, then we can directly go out in 15 rupees only. The cost will be 15. That will be the minimum cost. See, the answer is also 15. So how to identify, how to solve this problem? So we have to go step by step. So imagine you are here somewhere. Okay, you have to start now, and you have to choose whether to start from 1 or to start from 100. Okay, or whether to start from 0th index or to start from 1. Okay, so how you will choose? See, what if I say you don't have to choose? The function will choose by himself. What we have to do, we want to choose such a path that gives us minimum cost. Okay, minimum cost. We will make sub problems, right? We will identify the sub problems. How? See, we will make two recursive calls, and two recursive calls will stand for two calls. The first recursive call is choose 0th index, right? And the second recursive call will be for choose 1th index, start from 1th index. And finally what we will do, we will return minimum of these two recursive calls, right? 0th index and 1th index, right? We will return minimum of these two. Okay, and we have to do this for every step. How? I will tell you. See, we will consider this test case for making a tree diagram. Okay, so let us consider our price is 0 initially. Okay, and we are here. Okay, we have to enter. So we have two options: either start from 0th index or start from 1 index. So we will make first recursive call to start from 0th index. Okay, so I is equal to 0, and we make another recursive call to start from 1th index. Okay, now from 0th index we have two choices. Okay, and we have to pay only 1 rupee. So price will be what? Price will be 1, right? From 0th index. By paying this 1 rupee price, we can either jump on the next stair, or we can jump two stairs after this stair. Means if we climbed one stair, then we will be on 100. If we climb two stairs, we will be on 1. So these two choices we will make. So if we decided to go on the next stair itself, then I will be 1. We will be on the index 1, and the price will be what? Price will be, if from this stair we have to go beyond, then the price will be 100 rupees, and 100 plus before we paid 1 rupee, so the total price till now will be 1101. Okay, now we had another choice, that from the index 1, that is from this index 0, from index 0, either go on index 1 or go on the index 2. So if we chose to go on index 2, then the price will be what? This 1 plus the price of index 2, that is 1, that is 2. Okay, and we are on the second index now. Here also, if we started from this 1 index, from 100, then what we have? We have to pay price 100 to go further from this stair, and we have two choices, either go on second index or go on third index. So we will go on second index or we will go on third index. So now from second index, if we have to go further, then the price will be what? The price before, that is 100 rupees, plus the price of stair on the second index. What is that price? The price is 1. So 100 plus 1, that is 101. And from I is equal to 3, if we have to go, then what will be the price? Price 1. Okay, so the price will be also 100 plus 1, that is 101. 101. Okay, now again from the first index, right? From the first index, if we are standing on the first index, we have two choices, either go on the second index or go on third index, right? So if we went on the second index and we went on the third index, so we will make two choices again, that is two recursive calls. And finally what we have to do, we have to return the minimum out of these two recursive calls. Okay, because what we want the minimum cost of climbing. So if we are on the second index, then the price will be the total price will be added by the price of second stair. What is it? It is 1, that is 101 plus 1, that is price will be 103. Now if we are on the third index of this stair, then what we have to do, we have to pay the price 1 rupee. Why? Because 1 rupee price is there. So the 1 rupee will be added to our total price, that is 102. And from index 2, we have again two choices, either go on index 3 or go on index 4. Okay, so go on index 3 or go on index 4. So this choice we have, and then again the prices of that these stairs will be added. Can you notice one thing here? See, when we were here and we had to start, then what we decided, we decided either to start from 0th index or 1th index, right? But when we were on the 0th index, then again we chose whether to go on 1 index or 2 index. See here, whether to go on 1 index or 2 index. When we were on the 1 index, see here, when we were on index 1, then again we had to decide whether to go on this second or whether to go on this third index. See here, whether to go on second or third. And when we were on the second index, then again we had to decide whether to go on the third or whether to go on the fourth. Okay, so there is a repetition, and where there is repetition, there are sub problems, there is a recursion, right? So what if we made one function, that directly tells us which will be the minimum cost if we started from 0th index and which will be and 1th index. See, means we have this test case, we are here, we have to choose whether to start from 0 or whether to start from 1. So what we will ask the function to return minimum of function of, and we will give it a start index. So what the function will take as argument? The starting index. Okay, the start index it will take, and we will pass it 0 first, and then what we will pass? We will pass 1 to it. Means this function will return the cost if we started from 0. This function call will return the cost if we started from 1, and we will finally return the minimum out of these two calls. So finally what we will do, we will simply ask the function that what will be the cost if I started from 0th index. When we are on 0th index, we will ask the function what will be the cost if I started from 1th index or we started from second index. When we are on the index 1, we will ask the function what will be the minimum cost if I go on the second index, and third index. Out of these choices, what will be the minimum cost choice for me? And so we will ask this function. So here also there is one observation that, see, when we are on 0 index, then we can either jump on 0 plus 1 or 0 plus 2. When we are on the 1 index, we can either jump on the 1 plus 1 or 1 plus 2, that is 3. When we are on 2, we can either jump on 2 plus 1, that is 3 in third index, or 2 plus 2 plus 2, that is 4, fourth index, right? So this is the observation. If we are on 1, we can either jump on 1 plus 2 or 1 plus 1, that is plus 1 or plus 2. So what we have to return? We have to return the minimum of function of current index, that is start index, plus 1 comma recursive call for start index plus 2. Okay, this we have to return. So this is how we can make two recursive calls, and we have to return in this way. Now you can notice one thing, that see here, when we started from 0, we calculated for index, we calculated if we started from index 0, and what will be the cost if we started from index 1. Then again, what we did, we went from on 1th index, we started from 1 index, and we started from 2nd index. From 1 index we went on 2nd index, and for on 3rd index. But we have reached the 2nd index before itself, right? Before means here the recursion, the left subtree works first, and then it goes to the right subtree, right? So here itself we have calculated the value for I is equal to 2. Means if start index is 2, then what will be the minimum cost? That we have already calculated, and here we are calculating it again. Here also, see, what will be the minimum cost if we started from I is equal to 3, that is third index. We have calculated here, and here we are calculating it again. So to avoid this, what we will do, we will store these things. We will make one dictionary, right? We will make one dictionary, and this start index will be the key of the dictionary, and the value will be minimum cost. Means if we started from this 2nd index, what will be the minimum cost? We will store it in the dictionary. Then what will happen, when next time we want what will be the minimum cost when we started from index 2, then it will automatically take this value from dictionary without going beyond, right? So this will improve the efficiency of our function, and this is called as dynamic programming, DP, right? So we will see just remember these two things that they are important. Now we will see the coding part. As I said, we will make one function. That function will named as minimum cost, or we will call it as mean cost, and it will take only one argument, that is start index, as I told you. Now we have one base case. Just imagine that if this, whenever we are writing recursion, there is a base case, right? So here what will be the base case? If this start index is out of balance, that means if the length of our cost is 3, right? There are index 0, 1, 2, and if start index is 3, then what will happen? Error will be thrown. So to avoid that error, what we have to do, we have to write one condition, that if start index is greater than equal to length of cost, that is the length of that array cost, then what we have to do, we have to return 0. Why 0? Because see, okay, if we started from somewhere, and after climbing all the stairs we are starting, then the price will be 0. Why? Because we have the prices till the 2nd step only. After that, if we started from here, this blank space, there will be no any cost or no any price. There are no stairs, so that we will return 0. And if we have to talk programmatically, then we are returning 0 because we are adding this value to the cost, right? If we returned like none or something, then it will cause one error that integer and none cannot be added. We will simply return what? Firstly, the cost of this stair. Now we are on some stair, right? If we started from 10, then we have to pay 10 rupees first, and then we will decide whether to go on 15 or 20, right? Or if we are on 15, then we have to pay 15 rupees first, and then we have to decide whether to go on 20 or outside. So firstly we will write cost of start index, that cost we have to include, plus then we have to return what if we are on 10, we paid 10 rupees, and we have to decide what will be the minimum out of two paths, one path starting from 15, one path starting from 20, that is index plus 1, index plus 2, whichever is the minimum we are considering, that is minimum of mean cost of start index plus 1 comma mean cost of start index plus 2, right? Either, see, this is the recursive call for climbing one index or climbing one stair, and this is the recursive call for climbing two stairs, out of which whichever is the minimum that we are returning, right? Or what we will do, we'll make it as answer is this, and finally what we will do, we will return the answer, return answer. Okay, but as I said, there are repetitions. So as there are repetitions, we have to make one DP or one dictionary. We have to keep records, so we will call that dictionary as DP. Okay, we'll call it as DP itself because it is DP. So now what we will do, whatever answer we are getting, we will add that answer to the dictionary, that is DP of start index, right? Means when we have start index x, then we will see in this DP whether there is a value. If we started from x, is it already calculated? So what we will do, we will check it in the dictionary or in our DP. If start index in DP, is it in DP? Yeah, if it is in DP, then what we will do, directly we will return the DP of start index. Why? Because in our DP, keys are indices and the values are a minimum cost. That if we search that what will be the minimum cost if we started from second index, that is 2 index, then we have to check DP of 2. DP of 2 will be the minimum cost if we started from second index. So this is how it works. And finally what we have to return here, we were returning answer, so we will return DP of start index. Why? Because if it is not in DP, then we are storing DP of start index is equal to this something. And finally we have to return, see here we are passing one index, that is start index. So here firstly it is our choice either to start from 0, that is pass start index as 0, or pass start index as 1. Okay, so what we will do, we will pass both. Once we will pass 0th index, and then we will pass 1 index, and we will return the minimum out of it, minimum of mean cost of 0 comma means start from 0, start from 1, and whichever is the minimum out of these two, that we are returning. Okay, so this is how this function works out using DP and all. Yeah, it is running nice. So what we will do, we will submit. Yes, it is working fine.